Hello guys, this is the demonstration video for Kemet temperature thermal switches. So here you can see I have connected Arduino Uno with a Grow expansion kit. Along with that I have a temperature sensor on the left hand side bottom, and then a buzzer, and then a button switch. So I'm just tapping out the button switches to the temperature thermal switch here. So when I press this button, so it will complete the circuit, and here you can see that there is a change in the state of the connection, and it says it is connected, and also shows me the exact temperature where it started conducting, and also the magnetic field. So here I have a 3D magnetic sensor, so which can tell me the magnetic field in XYZ direction. So here right now I'm just using Z direction because we are changing magnetic field from the top, so by just moving the distance. So today I would like to demonstrate two uses, one with the temperature change and one also with the magnetic field change. So this is whole thing is powered through power bank. So here you can see, so this is a low power dissipating power bank, so that, like, which particularly means that it can even deliver very low current also. So here you can see in newer power banks it can deliver only up to certain threshold. Below that it will turn off. So here we have a power bank which is which can even give power at the rate of like 5 volt at 20 milliamps also. So this is best for our application. So yeah, let's start testing one by one. As you can see here, the room temperature here is around 31 degrees Celsius, and I have a multi-comp multimeter with a thermistor connected to it. So you can see here, so if I touch the thermistor, the temperature rises. So room temperature is around 31 degrees Celsius here. So at that time there is no conductivity by the thermal switch here. So right now I'm using MTRS 530B. So let's test by spraying freeze sensor. So freeze spray. So this is like a liquid nitrogen kind of stuff. If I spray it on the location, it will directly bring down the temperature. So I am placing it on the NTC thermistor here. So, and also there is a thermal switch. So right now it is connected through a jumper cable and tapped across the switch here. So yeah, so I have lowered the ISO so that you can see the display here. So yeah, right now I'm spraying on the uh, combination of thermistor on the bottom and also thermal switch on the top. So it started conducting. So you can see that the temperature had gone down to a very low, like 20 minus 25 degrees Celsius. So let's see when it starts, when it stops conducting. So right now you can see the temperature is rising. It's around 7 degrees Celsius now, 8.8, like that. So it is slowly raising the temperature, and let's see when we can record the temperature at which it stops conducting. So as you already know, because of Newton's law of cooling, so this takes more time. So actually I have a tape on the buzzer so that I can reduce the noise. So idea of buzzer came in such a way that I was using a multimeter to check the conductivity, and then I thought, okay, let me add a buzzer so that it visually and also through audio we can simulate there is a conductivity, and you can even see on the display there with proper signs and all. So the Grow kit really helped me because I can uh, like put a proper cabling here. So otherwise it would have been a mess of wires on a breadboard or maybe a puff board like this. So this, since I did not get a proper sensor, I got a small sensor in this small package and used a breakout board and some pull-up resistors and other stuff here. So the interfacing and code, everything is shared on GitHub. So let's see till when it starts. So I'm touching here so that it can raise temperature by a bit faster rate. So, and also I'm touching the temperature sensor too, so that they both record almost similar ranges. So we have crossed 30. Okay, we are near to 30 on the temperature sensor, and our thermal switch is still conducting. So let's see. So NTC is still coming to its original atmospheric temperature, and also our thermal switches. So I added this, and I thought this is a good way of testing, because we'll be able to see the continuous changes on the temperature through the display. So instead of connecting and to a serial monitor in a computer, I thought it's better to get it on the display directly, so that it'll be, the readings are transparent. So this is taking really long. I think I should have used a heater or so. Yeah, at around 29 degrees Celsius it started uh, like disconnecting, so which means like it is now completely disconnected from the uh, uh, first point to the second point, which means the switch is inactive now. That means, so we have recorded temperature of around 29 degrees Celsius, I would say. Thank you. So now I'll be testing the magnetic field test. So this will be this is a neodymium magnet. So I'll be placing the temperature sensor like this on a scale, and I'll be moving the neodymium magnet. Here we can see that's a centimeter scale. I'll be keeping it somewhere at the center of 6, and I'll be moving the magnet like this. So till the point where I'll get the conductivity. So here you can see that I got conductivity at around 6-7 mm probably. So I'll be simulating the same with a magnetic sensor here. So here is our magnetic sensor kept like this, and I'll be moving the uh, our magnet like this, so that it reaches around the same value. So here you can see that I have moved the magnetic sensor like this, and we have recorded a value uh, of around, for 7 mm distance, of around 10 milli or around 15 millitesla. So here this one is temperature switch, thermal switch OHD1 50B. So here I'm simulating with a fire here. So I'm increasing the fire blaze and just increasing it to a certain extent, so that it will stop the conductivity. And also you can see that there is a, yeah, you can see that the temperature has raised to 50 plus degrees Celsius, and the conductivity has stopped. Just by spraying some liquid nitrogen on the temperature sensor, it is back to the normal thing. So now you can see that it is still conducting. So yeah, that's how I tested this 50 degrees Celsius sensor. So I think this sensor particularly has best application in computer supplies and inverters, where the temperature goes beyond 50 degrees Celsius. You can turn on the fan. So this directly connected to a normally closed relay. So when the temperature crosses that 50 degrees Celsius, so the normally closed relay will definitely turn on, and definitely will be able to see the fan turning without any use of microcontroller or some complex logic. So that's one good application of this. So I'll also be testing the magnetic field application part in this one, but the thing is, since it is already conducting, so that issue will be there in this case. Yeah, use of magnetic field here is not helping because it is already conducting. Yeah. Similarly, I'd like to showcase one application of this thing. So in this application example here, you can see that the thermistor connected to a multimeter is reading a temperature of around 55 degrees Celsius. So this is because I am running a video on YouTube on this Raspberry Pi, so through an SSH connection, and this is powered through a power bank here. So what I was saying in this particular application is, so if you use this temperature sensor here, the OHD50B1, which can detect the crossing of 50 degrees Celsius, and if we can use this one for this particular Raspberry Pi model or any other computer applications, we can turn on the fan at that particular moment without using an external microcontroller circuit for that. Because so what definitely what you have to do is, using a transistor based NOT gate, you need to trigger the whenever there is a discontinuity in the circuit, so it will definitely turn on the transistors NOT gate, and it will turn on the relay. So basically you'll be having a simple circuit to turn on the fan. So yeah, the demonstration for discontinuity is here. So here the here you can see, so the temperature has raised to a certain extent, and also by placing this temperature sensor here on the Raspberry Pi, you can see that the OHD50B is like beyond the its Curie point, that is 50 degrees Celsius, so it is currently not conducting. So I'll be simulating by decreasing the temperature of this particular sensor. So here you can see that it is back in the zone and it is conducting, and I'll also bring down the temperature of CPU here. So that is also cool right now. Yeah, thanks for watching.